So far in this unit, we have discussed the way that metals bond to nonmetals, which is through the creation of an ionic bond, and how nonmetals bond to other nonmetals, which is the formation of the covalent bond. However, we have not yet addressed what type of bond is present either in a pure metal, like a lump of lead or a lump of gold or a lump of silver, or in what is called an alloy. An alloy is a mixture of two or more metals. So what kind of bond exists between metal atoms? We've discussed previously that the metal atoms need to give away their valence electrons in order to achieve stability and have an electron configuration similar to that of a noble gas. So what do they do if there's nobody around, if you will, to give those electrons to? The most common model, way of describing what's actually happening in there, sorry about that, is called the electron C model. As you'll see from the picture where the word C comes from, picture, if you will, a situation where we have metal atoms, and I'll explain why they have a plus symbol momentarily, in some type of a fairly organized arrangement. It's not nearly highly ordered as in the crystal for an ionic compound, but it's not nearly as disorganized and chaotic as what we find inside a covalent compound, where we just have groups of atoms called molecules moving around because they're usually liquid or gas form. Okay, these right here, these represent the metal atoms. Now out here we're going to draw some electrons. These are the valence electrons. And since I have drawn 8 metal atoms, in this case I've drawn 8 electrons, so this means that this would represent any alkali metal. This would represent any one of the alkali metals, because every alkali metal has one valence electron. Now what's actually happening here is that the model says is that the atoms kind of loosen their hold on the valence electrons so that the valence electrons are free to move from the orbital of one atom to the orbital of the next atom. So all of these valence electrons that you see here are in transit in between. They've left the valence electron of one atom and they're going right to the valence, going to the orbital of the next metal atom. So we call this the C model because it's like a sea of electrons all moving around, going from metal atom to metal atom. So the question is, well, why are these shown with a positive charge, and what is this actually? This right here is basically the nucleus plus all the rest of the electrons that aren't valence electrons. The reason it's shown with a positive charge is that because the electrons, the valence electrons, aren't really in their orbital anymore, they're kind of like halfway in between, this is a partially positive charge. The term we sometimes see for this is called a quasi-ion. The word quasi means part or half. So this isn't really an ion like you would find in a positive ion in an ionic compound. This is kind of similar to the same concept we talked about when we talked about bond polarity, and that this is partially positive. It doesn't have one full unit of positive charge because it hasn't lost one complete electron all the way. So what's the evidence, or what does this kind of tell us a little bit about metals, about the properties of metals? Well, the electron C model explains a couple of different things about metals. First of all, metals are flexible. The scientific term for being bendy and flexible is called malleable. Most metals, if you think about it, you can take them and bend them. Some of them are much harder to bend than others, like it's much harder to bend a bar of iron than it is to bend a piece of aluminum foil. But it still can be bent. So the model basically says is that all of that positive or negative charge makes it a unique, what we call rigid, yet flexible structure, right? Because the C moves easily in response to force. Okay. If you take a piece of metal, let's draw a little picture here for you, okay, and you hit it with a hammer, okay, you know the metal will bend or deform, you can dent it, but it doesn't shatter or break. And the electron C model basically says that all the positive and negative charge moving around, all the quasi-ions are all very strongly attracted to the moving sea of electrons. Another property of metals, okay, is that they're shiny. Okay. One reason for this is that since these electrons have a lot more mobility, they have a lot of different amounts of energy, they have the ability then to absorb and release a lot more wavelengths of light. And because the more wavelengths of light that are absorbed and reflected, or absorbed and released, the closer our eyes see those to white light. In this case it would be shiny. So when we look at metals, most of them tend to have like whitish or even silvery. There's a few exceptions like copper. Copper's electron configuration actually ends up giving it its particular color. Okay, and then the last property of metals that you should know in relation to the electron C is conductivity. Metals are great conductors of electricity. That's why we use them for electrical wiring. So how does the model explain the conductivity? Well, in order to have electrical current, you have to be able to pass. Electrical current is just electrons that are all moving in one particular direction rather than just randomly about. Okay, so if you put electrical current through a metal, you're basically pushing a stream of electrons in one direction through the metal. And the fact that you already have this moving sea of electrons makes it really easy here. I'm going to go back and erase that. It should say electrical, not electricity. Right, so a stream of electrons can move easily through the sea, which is already kind of moving just in a random direction. You can get everything to kind of stream in one direction. So as a result, we see that metals are very good conductors. The important thing for you to remember is not just what does the model look like and what are all the different parts of the model, but how does the model explain some of the properties of the metal. That's the important thing for you to remember.